Hey guys, Mr. Catlin here. We're looking at your homework problems for the week, starting with practice problems from 1.4. And let's jump right in. We're looking at this first problem, number 1, and all we have to do is select. So we should be circling some of these letters. We want to select all the statements that must be true. Must be true for any scaled copy. We're going to call it Q of the original. This is the original. We're looking at original polygon P. So they're going to make scale copies of this. Now, it could get bigger, it could get smaller. We just got to pick all the true things. Here we go. Side links are all whole numbers. So talking about the scale copy. So if I made a scale copy of this and made it look just like it, but maybe made it a little smaller or something like that, does every side have to be a whole number? Well, we don't know what the side links are right now. They might be decimals right now, and we could scale it in a lot of different ways that would change the size and the type of number. So they don't all have to be whole numbers. We don't want to pick A. Now, the angle measures on your new figure, okay? So let's think of this. We're thinking this is our copy, and we're going to call it polygon Q, all right? Now, are the angles all going to be whole numbers? Well, the angles right now are 35, 125, 250, 80, 135, and 90. And we know that when we make a true scale copy, the angles don't change. And all of the angles right now are whole numbers. So, yeah, all of the angle measures will still be whole numbers because they're not going to change. Q has exactly one right angle. Well, Q is a scale copy, and it's going to have the same angles, and the original has one right angle, and so the copy will too. So we definitely want to pick C. Now, if going from this figure to that figure had a scale factor of 1/5, like it says here, from P to Q is 1/5, then each side length, this side, this side, this side, this side, this side, each side length of P is multiplied by 1/5 to get the corresponding side length of Q. Yes, that's what we do when we have a scale factor. Every one of the sides gets multiplied to get the corresponding one, by whatever the scale factor is. If it's 1/5, then they all get multiplied by 1/5 to get the new copy. It would make it 5 times smaller. It would be 1/5 the size. Now, E, if the scale factor was 2, okay, so imagine that was 2, and we drew a scale copy over here that was times 2. Everything would get bigger. Well, how much bigger would everything get? Everything would get twice as big, right? So we'd have a twice as big figure as what it was in the first place. Would all of the angles double in size? Would this angle right here, this 90 degree, become 180? No, angles don't change. We don't want to pick E. And then the last one, F, Q, which is our copy, right, has 2 acute angles and 3 obtuse angles. The angles don't change. So let's say that we drew a copy. The angles would all stay what they were in the first place, all right? They wouldn't change any. This would be 80. This would be 135, okay? Acute means it's less than 90, and obtuse means it's greater than 90. So we've got acute, we've got acute, we've got obtuse, 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 greater than 90, and we've got a right, which is neither obtuse or acute. So we've got 2 acute and 3 obtuse, just like it says, and that would be true. And that's problem number 1. Let's look at number 2. Okay, so we got a quadrilateral here that's drawn on grid, and the grid printed a lot better this time for your copy, so you should be able to count these fairly easily. Now, we are being told that quadrilateral PQRS, which we do not see, has been drawn, and it is a scaled copy of ABCD. So imagine that we had a scale copy of our quadrilateral, and where A corresponds with P score is right here. P and A go together, and then Q and B go together, so Q would be here. It says that R corresponds with where C was, and S is where D is. Okay, so they've made a copy. All right, they've made a copy of that quadrilateral. And the only other information we know other than the corresponding parts is this. The distance All right, I'm going to notate it with a black mark from P to R, which would be this distance, which would be this distance. That distance on the copy is 3 units. Now, on the original one, we can actually count it 1, 2, 3, 4, 5, 6. On the original, it was 6. That gives us a lot of information. That tells us what they did. That tells us that they took this original copy and they scaled it by a factor of 1/2 because 3 is half of 6. So now we know a lot more information about this figure. Okay, it's half the size. It's half the side lengths. The angles didn't change, but all the sides are half as small. So that means that the distance from Q to S that they're talking about and asking us about, what is the distance from Q to S? That would be here. That corresponds from B to D, that purple line, which is 1, 2, 3, 4, 5, 6. It's also 6 in length up here. So it's 6 in length. So if our scale factor is half, that means Q to S is 3 units long. And it says to explain our reasoning, because what is our name of our shape here? PQRS. PQRS is half the size of ABCD. And B to D equals 6 units. 6 divided by 2 equals 3. That's how we got it. So there's our explanation in great detail. All right, let me move me up here. All right, so we're going to make one batch of lavender paint. This is actually something we won't talk about in class. This is a review of some ratio stuff you should have done in a previous year. So I'll throw this on there just to give you a little recap, review of things that you've done in the past, okay? You're making a batch of lavender paint. The ratio of cups of pink paint to cups of blue paint should be 6 pink to 5 blue. That's our ratio to get the color lavender, which is like a purple color. So pink and blue is going to make purple. We have to find 2 more ratios of these mixtures, okay, that are equivalent. Okay, so equal. So really they just want you to write 2 new equal fractions, okay? So think of it as like a scale factor. Pick a number, any number. I'm going to pick times 2 because I like to keep it simple. If I multiply the pink and the blue amounts by 2 each, the ratio should stay the same. And so I could mix, together 6 times 2 is 12, 12 pink cups of paint with 5 times 2 is 10 blue cups of paint. That would still make the same color lavender. It would just make a larger batch. That one would have 22 cups, where this one only had 11 cups. I could do another ratio, maybe that got bigger at a different rate. Let's say that I multiply by 3. That would be another easy one to do. That ratio, 6 times 3 would give me 18 pink, and then 5 times 3 would give me 15 blue. Now, I also could have shrunk them down to a smaller batch and done like half their sizes. I could have done like 3 pink because that's half of 6, and half of 5 is 2.5 blue. That would have kept the same color of lavender. So all of these are equivalent ratios, just like different scale factors to jump around within the particular ones that are there. And that is the first page of your homework. That's all of the 1.4 problems. It's good practice. Get those done. That's it for this video.